when I create a tensor, I can define its data type, what device it's going to run on, like GPU, CPU, etc., and whether this tensor requires gradient computation. If I run my G tensor, I have a vector, it's on float 32 data type, and it is running on my CPU. All right, operations. So I can add, subtract, and multiply 5 to each item inside of my H tensor. This is the results that I get. And I can also multiply one tensor with another tensor. So for every index, I can multiply, for example, 1 times 4, 2 times 5, and 3 times 6. So if I run that, boom, 4, 10, and 18. Now, when I do matrix multiplication, when I'm doing it with vectors, I'm adding up all of the items inside of the multiple of my H and my I tensor. So 4 plus 10 plus 18, what is that going to be? Yep, it's going to be 32, and it's going to be a scalar. Now, when I am doing matrix multiplication on matrices, there's one thing that you have to keep in mind. Here are my J and my K tensors. They are both a size of 2 rows and 3 columns each. But when I run matrix multiplication, it's going to run an error saying that these two shapes cannot be multiplied. The most important thing, now this is the most important thing, now pay attention. This number, the inner dimensions of both matrices must be the same. So this 3 and that value here must be the same. Since this is a 3 and that's a 2, we cannot do matrix multiplication at all. To change this, let's transpose the K the K tensor. Now my K is going to be a 3 rows and 2 columns. This is the shape that it produces, and this is the original J tensor. Now, once I run matrix multiplication on all 2 matrices, this is the resulting matrix that I get. It's just 2 rows and 2 columns of 14s. And I get 14 because when I multiply my 1 with this 1 right here, this 2 and that 2, I basically multiply the first row and the first column, the first row and the second column. That's the result that we get up top here. And for the second row, I multiply the first column and the second column to get these results right here. Now let's do linear function. Now a linear function is just going to equal y is going to equal the tensor that you provide times the random weight matrix plus whatever bias that you have added. I'm going to have a linear function without any bias. So now what I want to do is I want to have repeatability when I am making my random weight matrix. That's why I am using manual seed. I'm using manual seed 42. I am going to create my random weight matrix. It's going to make a shape of 2 rows and 4 columns. The out features are 4 and the in features are 2. And remember, my J tensor is a 2 by 3 matrix. So it's when I go to run matrix multiplication, it is not going to be able to happen since this value and that value are not the same. The inner dimensions are not the same. So I need to transpose my J tensor into a 3 by 2 matrix. I'm going to do that now. This is the matrix that it will provide. Now, when I go to run my linear function, I get a matrix of 3 by 2. That was my x. And when I run my output for my linear function or my linear matrix, I am going to return 3 rows and 4 columns each. Now, you can change the amount of out features that you want. Maybe you want to have 10 features, 10 out features. Boom, boom. Now you have 10 items inside of each row. And you can also increase it to as many features as you want. Let's say 99. Boom, boom. Now you have 99 features for every row. Awesome.